Hey everybody, this is A1 Math, and today we're talking about absolute value functions and how to graph them. First thing I want to talk about is the parent function. Here's a few different parent functions. Parent function is uh, what your graph would look like if you had no other operation other than that particular function you're talking about. Okay. Um, and with an absolute value function, all your is real similar to a linear parent function, except when the x values go negative, the y values stay positive. Okay, and when you have a graph or you have the function, you could do different things to make the graph uh, have a transformation. It could either slide to the left, slide to the right, go up, go down, and it could either have different types of compression. Okay, first thing I want to do is give you the steps for graphing an absolute value function. Step one, you want to find the vertex. Step two, you want to graph with a T-chart. And step three, you want to describe the transformation. So, in order to find the vertex, you want to take a look at the graph, and it's usually in this format located here. And the key numbers you want to focus on is the H and the K as far as finding the vertex. The H and the K. Okay. There'll be the indications in order to find the vertex. So 5 and -2 is what we have here. Now notice how you have a negative already in the formula. So we're not going to use this negative. We're going to use just the 5. So our x value is going to be 5 and our y value is going to be -2. So I've got it graphed here. Now, our next step is to graph with a t-chart, okay? So we're going to enter in values for our x and then get out values for our g of x. And that's what we're going to plot in order to get the graph. Okay, now, in order to figure out what values you want to use, I recommend going a couple of numbers to the left and to the right of your x-axis. So a couple numbers to the left of the 5 and a couple numbers to the right of the 5. So I've got 3 and 4 to the left of the 5, and 6 and 7 to the right. Okay, so I'm going to take each x value and plug it into this equation here and get out a g of x. So when I'm plugging in my 3, I'm going to replace the x with 3 and solve. Don't forget, when you solve, you want to take the absolute value. So if you have 3 minus 5, that's going to get you -2. And then you take the absolute value of -2, which is +2, multiply that times your 4, then subtract your 2, and you get 6. All right, the next thing I'm going to do is plug in my 4. When I plug in 4, I get 2. Next, I'm going to plug in 6. And when I plug in 6 for my value, I also get 2. And last, I'm going to plug in 7. And when I plug in 7 for my value, I get 6. Okay. And you could take any set of points here to graph. I just chose 4 and 2 and 6 and 2. It's good to go ahead and do about 4. That way, in case you get a fraction or something that's hard to graph, you'll be able to look at another set of points. Okay, so we've used the t-chart to graph the function. Now what we want to do is determine what happened to it. I mean, how did the parent function change? So as you can see here, or in blue, we have the parent function. So not only did it shift to the right 5 and drop 2, it also got compressed or pushed in um, vertically. So it kind of got stretched so that these two lines came in and go up. So you need to be able to describe what happens to the function. So remember, you want to follow your steps. They are find the vertex, graph with the t-chart, and then describe the transformation. Let's take a look at another example. Okay, as we take a look, remember our first step is to find the vertex. So I can see my H and my K right here, but remember the H already has an automatic negative. So in order for this to be positive, the 3 had to have been negative. Negative times a negative is going to make this positive. So when we graph our vertex, we will make sure that it is a -3, -3, okay, and our +1. So our vertex is going to be to the left 3 and up 1. Okay, then we're going to graph with a t-chart. So I'm going to plot 2 points to the left and 2 points to the right. So I've got -5 and -4 and -2 and -1. Okay, now when I plug in my -5, um, notice how on the previous problem, the 4 was outside the absolute value, but this time it's inside, okay? You've got this -1/2 that's inside the absolute value. So you want to make sure you multiply before you take the absolute value. So as I plug in -5 plus 3 is going to get me a -2. -2 times -1/2 is going to get me a um, +1, and a +1 plus 1 is going to equal 2. I'm going to go ahead and plug in my -4. And as I plug in my -4 and compute the problem, I'm going to end up with a 1.5 or 1.5. Okay. Next, I'm going to go ahead and plug in my -2. And when I plug in my -2, I also get a 1.5. Right. And when I plug in -1, I'm going to get 2. Okay. And I choose to plot these points here. They seem like the easiest ones to work with. And then I'm going to go ahead and put the graph I have and the parent function here in blue. And as you can see in comparison, comparing the new function from the parent function, uh, it's been stretched out horizontally. It's going wide. Okay? And this is how to graph a absolute value function. Remember, you're going to find the vertex, graph with a t-chart, and then describe the function. And thank you and see you next time.